Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now let's get started on our set of questions for today's session. Okay, so question 1 asks, how can I calculate delta G of a reaction? Okay, so first I'll just write the definition of delta G. So delta G is the change in the standard free energy of a chemical reaction. And it stands for Gibbs free energy. Okay, so delta G can be calculated using the following equation, where delta G is equal to delta H minus T times delta S. So delta H is the enthalpy of the system. And delta S is the entropy of the system. Okay, so I'll also write how to calculate both delta H and delta S. So delta H can be found by taking the delta H of your products minus the delta H of your reactants. And similarly, you can do the same thing for delta S, where delta S is equal to delta S of your products minus the delta S of your reactants. Okay, so let's see what the junior tutor said. The standard free energy of a chemical reaction G is also called Gibbs free energy and can be computed using G is equal to H minus T times S, where it is defined as the difference between the enthalpy of the system, H, and the product of temperature and T, and entropy S of the system. For the change in Gibbs free energy present in a chemical reaction, this can be calculated via delta G is equal to delta H minus T times delta S for constant temperature systems. The enthalpic change in the system can be easily calculated by subtracting the enthalpy of the product on the enthalpy of the reactants. Yep, so delta H is equal to delta H of your products minus delta H of your reactants. Similarly, the entropy change in the chemical reaction is computed in the same manner. Yep, so the solution is correct. And now we can move on to question number 2. Okay, so question 2. What are quantum numbers? And what information do we get from the quantum numbers n, l, and ml? We define a spin quantum number ms, but we do know that an electron literally spins. Okay. So quantum numbers are a set of values that are assigned to each electron. So every electron in an atom will have a different set of quantum numbers. Okay, so first we have our n value. So the n number stands for principal quantum number. And what the energy value kind of stands for is that it represents the energy level of the electron. And some people refer to it as the shell. Okay, so the second quantum number is your L value. So the L value shows the orbital angular momentum. Which is representative of the shape of an orbital. And it can be found because it is just your n value minus 1. So on the right, I'll just write down here. If your L value is 0, then you are in the s orbital. If it is p, your L value is 1. You're in the d, your L value is 2. And if you're in the f, your L value is 3. Okay, so next we have your ml value. So your ml is the magnetic quantum number. So your ml values show the number of orbitals in a certain subshell. And generally speaking, it can range from negative L to positive L. So for example, if your L is equal to 2, then your ML ranges from negative 2 all the way up to positive 2. Okay, so lastly, we have your MS. So this tells you the electron spin. So your MS value can either be positive half or negative half. So basically, we know that each orbital can have 2 electrons. And one of them spins up and the other spins down. So when it spins up, then your MS value is positive half, and when it spins down, then your MS value is negative half. Okay, so these are all the different quantum numbers. So let's see what the junior tutor said. Quantum numbers are a set of values that can be assigned to each electron that, when all electrons' quantum numbers are accounted for, should have a wave function that should comply with Schrödinger's equation. There are 4 quantum numbers that can be used to describe an electron. Shown below are the details we could get from each quantum number. 1 is the principal quantum number. The principal quantum number is a positive integer that describes the energy level of the electron. Oftentimes, the term shell can be used to describe this quantum number. 2, we have the orbital angular momentum, L. The orbital angular momentum describes the shape of an orbital. Its value can range from 0 to n-1. For example, if the principal quantum number is 4, then the possible values for the orbital angular momentum are 0, 1, 2, 3. Each of these values describes different types of subshells. Moreover, an orbital angular momentum with a value of 0, 1, 2, or 3 is often referred to as S, P, D, or F subshells, respectively. Okay, so next we have the magnetic quantum number, ML, which describes the number of orbitals present in a certain subshell. The permitted values for this quantum numbers are integers from negative L to L. If the orbital angular momentum has a value of 2, then the magnetic quantum number has 5 possible values: negative 2, negative 1, 0, 1, or 2. This means that in the D subshell there are 5 orbitals present. Lastly, electron spin, ms. The last quantum number describes the spin of the electron. This can be either positive half or negative half. By convention, a positive half spin is denoted as an up arrow, while a negative half spin is denoted as a down arrow. Moreover, in each orbital there can only be 2 electrons, and these 2 electrons must have opposite spins. Although electrons themselves do not literally spin, they have measurable angular momentum. In classical systems, angular momentum is associated with a spinning object. For this reason, the term electron spin was used. Yep, so great answer. And we can move on to question number 3. Okay, so question 3. How would you rank these ions according to atomic radius? K+, calcium 2+, phosphorus -3, sulfur -2, and chlorine -1. Please explain why you chose this order. Okay, so let me write down the basic trend of the periodic table for atomic radius. So generally, atomic radius increases as you go right to left. And as you go from the top to the bottom. Okay, so let me look up how to show this on the periodic table. Yep, so you can kind of see in these different examples how it kind of like ranges. So obviously when you start from the top and go down, you'll notice that the radius gets larger, and this is because more electrons are in the atom. So for example, like when you have lithium, sodium, potassium, they all have the same number of valence electrons, so they all have 1 valence electron. But the difference is that as you go down, you increase the size of your atomic radius by another level of electrons. And you'll see that atomic radius increases when you go right to left. So meaning the elements that are more on the right, they contain more protons than as you go than the very left. So because they contain more protons than the other elements in that row, since it's more positively charged, this tends to bring your valence electrons more into the shell. So this is why atomic radius increases when you go right to left. So this is a nice diagram as well. So the question gives us potassium plus calcium 2 plus, phosphorus 3 minus, sulfur -2, and chlorine -1. So potassium is the smallest, and chlorine is the largest. Okay, so if you look at a periodic table, you can find calcium and potassium right here, and phosphorus, sulfur, and chlorine kind of at the row above it. So did they rank them? Oh no, they didn't yet. So if we were to rank this, we have to first look at how many electrons are in their shell, since we know that the number of electrons will affect the atomic radius. So calcium is right here. If you were to take away 2 electrons, its shell is smaller, and you have the same electron configuration as argon. If you were to take away 1 electron from potassium, you also get the same electron configuration as argon. And you'll notice that even when phosphorus loses 3 electrons, and when when phosphorus gains 3 electrons, and when sulfur gains 2 electrons, and when chlorine gains 1 electron, they all have the same electron configuration as argon. So this means they all have the same number of electrons. So what we're more interested in is how many protons are in each element. So for this example, all contain the same number of electrons. So this is when atomic number will have a say in the matter. Okay, so like I mentioned earlier, the more protons that you have in the nucleus, the more it will attract those outer valence electrons, so it makes your radius smaller. So the element that has the largest number of electrons is the calcium. And notice it's also the element that lost the 2 as well. So calcium will have our smallest. This one wasn't in order. I'll write it in order here. Calcium has the smallest, since it has the highest number of protons. Next is potassium plus. And then next one is the chlorine. And then the sulfur. And then lastly, the phosphorus has the largest atomic radius. And another helpful note for when you are just comparing just a neutral atom compared to its ion, I'll just write it here. In general, the negatively charged anions have a larger atomic radius than its neutral ion. Or neutral atom. And this is because you're adding an electron to the shell, so your radius gets larger. And similarly, the cations have a smaller atomic radius than its neutral atom. Okay, so this is just when you need to compare an atom that lost or gained an electron. But in the case of the example that was in the question, since all of them had the same number of electrons, we just needed to look at atomic number. Okay, so the junior tutor said, the number of electrons in all 5 ions are equal, so they all contained 18 electrons, due to the losing and gaining of electrons from its ground state. For example, the original ground state of calcium has 20 electrons, thus calcium plus 2 ion, which loses 2 electrons, now has 18 electrons. Phosphorus, on the other hand, originally has 15 electrons, which gained 3 more electrons in the p-3 ionic state. To determine the atomic size of atoms, the number of protons should be considered, since a higher number of protons will result in a stronger pull of electrons towards the nucleus, thus decreasing the atomic size of the ion. The order of the increasing number of protons in the periodic table is calcium plus 2 is less than potassium plus, which is less than the chlorine minus, which is less than sulfur minus 2, which is less than phosphorus minus 3. Yep, so this solution is correct. Okay, so on to question number 4. A blank refers to 2 or more atoms held together by covalent bonds. So the answer to this one is just a molecule. So for example, let's say we had a hydrogen atom, an oxygen atom, and another hydrogen atom. These are just separate atoms, but once I draw covalent bonds, it now becomes the water molecule. So if we look at the other options that they give us, community doesn't really make all too much sense. A shell, no. We know it's not ion because an ion is just a charged atom. Let me write that down as well. So an ion, you can just say it's like an atom with a charge. So it either lost or gained an electron. And then molecule was the answer. And then we also have isotope. So an isotope is when you have an element that has the same number of protons, but a different number of neutrons. Okay, so the answer is molecule. Okay, so the junior tutor said, covalent bonds are a result of the bonding of atoms of elements. This forms compounds and they are composed of molecules. So the correct answer from the choices is D. Yep, so the solution is correct. Okay, so question 5. What is the structure of glutamic acid? So the short 3-letter word for glutamic acid is just glue. So this is one of the examples of an amino acid. And all amino acids contain the following. They all have an amine group. And they all have a carboxyl functionality as well. But the only thing that makes every amino acid different is its R chain. So in the case of glutamic acid, its R group just has 3 carbon, 1, 2, 3, carboxylic acid group. Okay, so I'll just put that in a box. So this is its R group. So the R group of an amino acid is what makes each of them like unique. Since they all have an amine and they all have a carboxyl group. Okay, so let's see what the junior tutor said. Okay, so notice that they have the same structure, except it's kind of like flipped. So they have their carboxylic functionality here. And then on the same carbon, this on the left would be the R group. Yep, so the solution is correct. Okay, so question 6. For the following battery, cadmium solid, cadmium 2 plus, chlorine minus, chlorine, and carbon, what is the reduction half reaction occurring at the carbon electrode? Include physical states of reactants and products, and the standard potential of the reaction is 1.4 volts. From which electrode will electrons flow from the battery into a circuit? Is it the cadmium electrode or the carbon electrode? 3. What is the mass in kilograms of chlorine that is consumed? If the cell delivers a constant current of 713 amperes for 30 minutes. Okay, so first let's write down the battery that is given in the question. run out of room. Let me just start writing it from the left. Okay, so next let's try to write both of the half reactions down. So the first question asks, what is the reduction half reaction occurring at the carbon electrode? So the reduction reaction takes place in the cathode. And the reaction that takes place is the chlorine which has an oxidation number of 0. So I can write that in as well. So it gains 2 electrons to form 2 chlorine minus ions. And the standard potential of the reaction is 1.4 volts. So I can write here at the end 1.4 volts. So the question didn't ask for it, but I'm also going to write the oxidation reaction. So the oxidation reaction takes place in the anode, and it is our cadmium solid, which starts off with an oxidation number of 0. And it gets oxidized to cadmium 2+. And this is because it lost 2 electrons. So a way I like to remember how to figure out which one is the oxidation reaction and which one is the reduction reaction, you can use the term oil rig. So basically it means that oxidation is losing electrons. So here you can see here the cadmium lost 2 electrons and became cadmium +2. And reduction is gaining. So reduction is gaining electrons, and that is the case of the chlorine. Each chlorine atom gained an electron, and we got 2 chlorine minus ions. Okay, so these are both of the half reactions. So this was part 1 of the question. So part 2, from which electrode will electrons flow from the battery into a circuit? So we need to see where the electrons are being generated, and they're being generated in the anode. And we know that because in our oxidation reaction, you can see that the electrons are a product. So our anode is the cadmium electrode. Okay, so lastly, part 3. What is the mass in kilograms of chlorine consumed if the cell delivers a constant current of 713 amperes for 30 minutes? Okay, so first we need to find the charge. So the charge has a units of coulombs, and it is equal to current, which is in the amperes, multiplied by time, which will be in seconds. So charge can be denoted as Q. And our current, they said, was 713. And for time, they gave us the time in minutes, but we just need to convert it to seconds in order to finish off the calculation. So we just need to multiply 30 minutes by the conversion factor, 60 seconds in 1 minute. Okay, so this gives us a charge of 1,283,400 coulombs. And the reason why the units converted to coulombs is because the units for amperes is equal to coulombs per second. Okay, so now that we have our charge, we need to find the number of moles. And to do that, number of moles is equal to charge over Faraday's constant. So this gives us the number of moles for electrons. So let's just plug in our charge, which we found in the previous step. And Faraday's constant is 96,485 coulombs over moles of electrons. So this gives us 13.301. And we need to divide this number by 2 to get the moles of chlorine. So this gives us 6.65 moles of Cl2. And then lastly, I'll try to fit it at the bottom here. We just need to use the equation where number of moles is equal to mass over molar mass. Let's rearrange it to solve for mass, which is number of moles, so 6.65 moles of Cl2 times the molar mass of chlorine, well, Cl2, which is 70.90 grams per mole. So this gives us a mass of 471.54 grams. And to convert to kilograms, we just need to divide this by 1,000. So finally, this gives us 0.472 kilograms. Okay, so let's see what the junior tutor said. The reduction half reaction at the carbon is the... Yep, so then they just show the reduction reaction of the chlorine being reduced to Cl minus. Okay, so that part's fine. To answer this, we must first know which side is the cathode and which is the anode. The anode is typically where the electrons will flow out from, and also where adductions occur at. However, the cell diagram given shows that both species undergo reduction. Since we know that the cell is a battery, the reaction must be spontaneous and have a positive E cell value. The potential of the reduction of cadmium 2 plus to cadmium solid is negative 0.408 volts. Since that value is born negative, then 1.4 volts, the anode is the cadmium, while the cathode is the carbon. The electrons would flow from cadmium to carbon, thus the answer is A. Yep, so A was the cadmium electrode. Moreover, the correct cell diagram is... Okay. So they just kind of rearranged the two chlorines to show the flow of electrons more realistically. Part 3. To answer this question, we just need to perform some dimensional analysis. First, we compute for the amount of electrons produced. Note that A is also coulombs per second. So mole of electron is equal to amperes times seconds times Faraday's constant. So they put it all in one step. So they have 713 amperes multiplied it by 30 minutes times 60 seconds per minute. And then they divided by 96,485 and got 13.301 moles. After getting the amount of electrons produced, we can relate that to Cl2 through equation 1. Yep, because chlorine needed 2 electrons to react. So that's why you divide it by 2 moles of electrons, multiply it by Cl2's molar mass, and then divide it by 1,000 to get the answer in kilograms. So they got around 0.05, which is similar, but maybe there was like a calculation error in one of the steps. But I'll just say that this solution is correct. Okay, so on to question number 7. What do you call the bond between water molecules? So notice that they use the word water molecules, so they don't ask for the bond of a hydrogen to an oxygen inside a water molecule. They're asking for the bond that takes place between every water molecule. So this bond is called hydrogen bonding, or hydrogen bond, sorry. Hydrogen bonding is what takes place. So the definition of hydrogen bonding is the attractive force between an H atom that is covalently bonded to an electronegative atom. So in the case of water, the electronegative atom is oxygen, but other electronegative atoms can be like nitrogen or fluorine. So it's the attractive force between a hydrogen atom covalently bonded to an electronegative atom and another electronegative atom. So it makes more sense if you actually kind of draw out what's happening. So first, let's write down the molecule of water. So oxygen is more electronegative than both of the hydrogens. So there's going to be a non-zero dipole moment going towards the direction of the oxygen. So that shows that there is an uneven share of electrons. So because of this, the side that has the oxygen is partially negative, and the side that has the two hydrogens are partially positive. So this partially negative oxygen can attract another water molecule because it also has a partially positive side and a partially negative side. So this attractive force is what's called a hydrogen bond. So it's not literally a hydrogen bonded to the oxygen in a water molecule. It's that attractive force, which is actually pretty weak. Let's see what the junior tutor said. So the water molecule is consisted of two hydrogen atoms bonded to an oxygen atom. Its overall structure is bent due to the electronegativity difference in the oxygen atom. Oxygen atom forms hydrogen bonding with the H atom and also carries two unshared electrons that cause the difference in electronegativity. I don't know if they kind of worded that correctly. So they also kind of assumed that the bond between the oxygen and the hydrogen is called the hydrogen bond, but I'll probably correct that down here. So water is polar in nature. The bonds formed by the hydrogen atoms with oxygen are called hydrogen bonds. Hydrogen bonds are weak interactions formed between hydrogen with a partial positive charge and a more electronegative atom. In this case, oxygen. Hydrogen can also form hydrogen bonds with other electronegative atoms such as oxygen, nitrogen, or fluorine. Okay, so I'm just going to correct the answer. Okay, so I'm just going to say this solution was incorrect since I don't think they really understood what hydrogen bonding actually was. Okay, so question 8. Identify which of the following characteristics apply to fission, fusion, or both. So fission is when a heavy molecule or a heavy and unstable nucleus splits into two lighter nuclei. And fusion is kind of like the opposite. So fusion is when two lighter nuclei are combined and this results in energy. Okay, so let's make a table of fission, both fission and fusion, and then fusion. Let's look at their options. Involves the transmutation of elements. So this is actually both of them. Okay, so the next one, its process is used to generate electrical power. So this is an example of fission. The next one, predominantly in the interior of the sun. So this is fusion. So there's always two lighter nuclei combining in the sun, resulting in all that energy. Heavily involves neutrons. So this is fission. High temperature is required at the initiation of the process. So this is part of fusion. Then lastly, radiation is emitted during the process. This is for both of them. Okay, so let's see what the junior tutor said. Fusion and fission are nuclear reactions that produce energy. When two light nuclei combine together, resulting in vast amounts of energy, the reaction is fusion. Fission is when a heavy and unstable nucleus splits into two lighter nuclei. Okay, so they have a table here. Fusion predominantly in the sun. Yep. High temperature is required. Fission, used to generate electrical power, heavily involves neutrons. Both of them involve transmutation of elements, and radiation is emitted during the process. Yep, so this solution is correct. And I think we have time for one more question for this session, which just asks, how do you balance the equation for the combustion of octane? So the chemical formula for octane is C8H18. In combustion, this is reacted with oxygen. To form CO2 plus water. So whenever we need to balance the combustion reactions, I like to first balance my carbons first, because typically balancing the carbons, you just see that whatever hydrocarbon you start with has a certain number of carbons. So in our case, octane has 8. So all I need to do is add an 8 in front of CO2. And then next, I like to balance my hydrogens. And this is because if I tried to balance my oxygens now, then and I put a coefficient in front of H2O, then my hydrogens get affected. So that's why I like to balance my hydrogens first. So again, let's look at octane. It has 18 hydrogens. So I just need to put a 9 in front of H2O. So now our hydrogens are balanced. And now I like to balance my oxygen. So we have 16 plus 9, which is 25. So you just put 25 in front of O2 and then divide it by 2 to balance out the equation. But if you don't want to have a fraction, you can multiply this whole thing by 2 to get C2C8H18 plus just normal 25 makes 16 CO2 plus 18 H2O. Okay, so the junior tutor said, first, list down the number of atoms for each element on both sides. So this is a longer way of doing it. Then balance the carbon, yep. Balance the hydrogens by placing a 9. And then to balance the oxygen, put a coefficient of 25 over 2. And then they also showed it if you were to get rid of the fraction. And they got the same answer as me. Okay, so the solution is correct. Okay, so those are all the questions for this session. And if you enjoyed today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also don't forget to leave a like and a comment if you enjoyed today's video. And also if you wanted to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.